Okay, here's a second example problem for these linear versus exponential equations. This is problem 2. So a town with 27,500 people shrinking by 600 each year. We know that that is a linear equation. It's shrinking by the same amount each year. So it's going to be y equals mx plus b. So y equals negative 600 because it's shrinking by 600. So it's going to be going down 600 every year. So where x is the years. And starting at 27,500. So there's our linear equation for our first situation. Our second situation is clearly going to be the exponential one. 4.2%. It's shrinking by this by a more and by a percentage each year. So it's being multiplied over and over again by a number. But we have to find out what that number is. We have to know what our base is. It has something to do with the 4.2%. But remember, it's going to be 1 minus 4.2% because it's shrinking. We're going to subtract this 4.2% from 1 because the number has to be less than 1 in order for it to be shrinking. So what would that be? So use your calculator is probably the best way to make sure you don't make a mistake. So 1, now take away 4.2% from 1, and 4.2% is 4.2 divided by 100, so that's 0.042. So that's going to be my base. It's 1 minus 4.2%. 4.2% divided by 100. You move the decimal point over 2. So it's 1 minus 0.042. So that's my B. So now going back into, with my pencil here, I'll get my exponential equation. So it's y equals 27,500. So our start, oops, what did I do? 25 for. So 27,500, no, not minus. There's never any minuses in exponential equations. You just multiply it by a number either greater than 1 for increasing or less than 1 for decreasing. Here it means decreasing. 1 minus 4.2% or 1 minus 0.042, which is 0.958. There's my base times, to the power of x. It's being multiplied over and over again by this number. That's smaller than 1, hence it is shrinking. Okay, so we're going to go into our graphing calculator now and enter these two equations. So remember, you have to click on the y equals button. And let's put in our linear equation, negative 600x plus 27,500, our linear one, and then get our exponential one starting at 27,500. And it's being multiplied by a number less than 1, so it is getting smaller and smaller every year. That's what our x to the power of x means. Okay, so now we gotta go look and see what our table looks like. So hit second graph, we get to our table. And there's our table for both functions. I am not going to fill out my tables up here, so it'll take me way too long and you'll get bored. So I'm going to look at my tables to set up my two axes. So let's start with the linear equation. And let's use a blue pencil. Starting with our linear equation, and we're going to, starting at 27,500, we're going to set up our y-axis. So you need to count first you need to put your scale on here. Let's count the number of spaces. There are 28 spaces here, and notice how I set that up on purpose because you need to go up to 27,500, and so that this space is going to be 28,000. So it's going to be going up by 1,000 each time. So 1, 2, 3, 4, 5, 5,000. And then going up 1,000 each time. Make sure your increments are equally spaced. So 5,000, and then 6, 7, 8, 9, 10,000. and then going up by 1,000 each time after that. 10,000, and then 11, 12, 13, 14, 15. Notice how I'm not putting every single number along the y-axis, because that just, not only does it create a lot of extra work, but it clutters up your axis. It's enough to put in every 5,000. 15, 16, 17, 18, 19, 20. 20,000. So, man, one of the common mistakes to make is to not have your numbers spaced properly. So that makes sure that there's always the same number of spaces so that each increment is worth 1,000. 20, 21, 22, 23, 24, 25,000. And then you can see that it goes up to 28 at the top. So 25,000. So I know that's going to get my 27,500. Then we'll fit on this. It'll be right there. But now let's set up our x-axis. We need to go up to 50. There are 25 spaces here, so I'm going to make each one worth 2. So 20, because I need to go up to 50. So 2, 4, 6, 8, 10. And then 10, 12, 14, 16, 18, 20. This is my years. Number of years. 20, 22, 24, 26, 28, 30. Again, notice that I'm not putting in every single year because it just would make a big mess. It'd be clutter up my axis. 32, 34, 36, 38, 40, and be a lot of extra work. 40, and then finally up to 50 years. So you should label your axes time and years down here and number of people. I'm not going to do that because it will take me too long. Anyway, so now we are ready to make a graph. I'm just having fun changing the colors of my pencil. Let's do our linear equation in green. So we're going to start at 27,500, 25, 26, 27. So that's going to be right there. Actually, both of them are going to start in the same place. The 27,500, and then at 5 years, it's going to be, oops, notice how I forgot to show you that you really should change your table in order to see this table set, to have it go up by 5s. Okay, so now I can, when I go back to my table, I can see it going up by increments of 5. So now at 0 years and 5 years, 10 years, 15 years, which looks exactly like, or just like what you have here, so you can put in your numbers. So at 0, 27,500. At 5 years, this is 24,500. So 5 is right here. 5 years and 24,000 is there's a 24,500. Oops, I forgot to bring me a pencil back. 24,500 is right there. And then at 10 years, it's at 21,500. At 10 years, 21,500. Oh, yeah, see, I made a boo-boo here. You always check. It's hard. The biggest mistake here to make is to go off on your plot. And you can see, because it's supposed to be linear, I could see that I made a mistake there because the points were not lined up. Okay, now those are falling on a line. So at 15 years, it's 18,500 and so on. I'm not going to plot all of them. 16, 17, 18, 18, 5. See, again, I am just doing a really bad job here. I think the reason why I did that is because I had that one off. So this 10 also has to, remember, I had it at 10 and 21,500. Aha, okay, so your points should all fall on a line. I'm not going to put them all in here because I don't really need to, because since they fall on a line, I can just scroll down to, let's see, 40, 50 years. And also at 50 years, it's at negative. 45 years, let's put in the 500. So 45 years, it's at 500. So put my pencil back on. 45 years is right there, and it's at 500. So there's one of my. So now, if you take a ruler and try to draw a line that goes through all of these points, and you can probably do a much better job than me with my virtual pencil. But hey, I didn't do so badly. So notice that 50 years is actually going to end up below the x-axis. It's going to be negative, which doesn't really make any sense for a situation. You can't have negative people, well, unless they're like, well, that would actually, it wouldn't make sense at all. Let's change to a red pencil for the exponential. So we're going to graph the exponential. It also starts at 27,500. And then I need to get back up on my table to see what it is at 5. It's going to be 22.1. So at 5 years, 5 years is, make sure I get my 5 correct. Oh, it's going to be 5 at 21, 22. What am I using? It's 22, 190. So 22, it's right about there. It's always approximations. At 10 years, it's 17.9. So this is 15, 16, 17, 18. There's a 79 is going to be right there. And then at 15 years, it's going to be at 14.4. So 11, 12, 13, 14, 4 is right about there. And then at 20 years, it's at 11.6. So 10, 11, 6. So that's about there. 11,600. And at 25 years, it's at 9,407. So this is 10,000. So 9,000 is here. 94 would be right about there. And at 30 years, it's at 7,591. So 5,000, 6,000, 7,500 would be there. 7,591 is about there. And now I'm going to scroll down further on my table to see 35, 40, and 50. So 35, got to go back to my pencil. 35 is at 61.25. So 5, 6. See, oops, now it's above the line. 61, 5, 6. So it's right about there. And then at 40, it's 40 years. It's at 439. At 4942 at 40 years, 4942. So this is 5,000. So it's right about there. It's really close to 5,000. And then at 45 years, it's really close to 4,000. So this is 5,000 right here. So 4,000 is right there. And then at 50 years, it's at 328. So 1, 2, 3. It's right about there. So my exponential, see how it starts off, and it sort of starts leveling off here. It starts to level off more and more. Hey, that's pretty good. So that's about all I'm going to do here for this video. You can see by looking at your graph right about where it crosses, and you can also see on your table about, so here you can see it's somewhere in between 30 and 35 to 40. Here it's going. It's somewhere around here. It's crossing. Like they're going to become about the same. So that's about it. And thanks for watching. Bye.